Every day, we look up and see the same beautiful color above us, blue. It feels normal, almost boring, because it has always been there. But have you ever stopped and asked a simple question: why is the sky blue? Why not red, green, or purple? To understand this story, we must first travel to the sun. The sun looks yellow to our eyes, but in reality, sunlight is white. This white light is made of many colors combined together: red, orange, yellow, green, blue, indigo, and violet. We can see these colors clearly in a rainbow, where sunlight is split into its individual colors. Now, let's come back to Earth. The Earth is surrounded by a thick layer of gases called the atmosphere. This atmosphere is made up of tiny molecules like nitrogen and oxygen. These molecules are so small that we cannot see them, but they play a huge role in coloring our sky. When sunlight enters the Earth's atmosphere, it doesn't travel straight to our eyes. Instead, it collides with gas molecules. When this happens, the light gets scattered in different directions. This process is called Rayleigh scattering. Here's the key part of the story. Not all colors scatter in the same way. Colors with shorter wavelengths, like blue and violet, scatter much more than colors with longer wavelengths, like red and orange. This means blue light spreads across the sky in all directions. You might wonder, if violet scatters more than blue, why isn't the sky violet? That's a great question. There are two reasons. First, the sun emits more blue light than violet light. Second, human eyes are much more sensitive to blue than violet. Because of this, our eyes perceive the scattered light as blue, not violet. This is why, when you look up during the day, the sky appears blue from every direction. But the story doesn't end here. Have you noticed that the sky is not always the same blue? Sometimes it is deep blue, sometimes pale, and sometimes almost white. This depends on how much atmosphere the sunlight passes through. At noon, the sun is overhead, and light travels a shorter distance, making the sky a deeper blue. In polluted or dusty air, scattering changes, and the sky can look dull or gray. Now let's talk about sunsets. During sunrise and sunset, the sun is low on the horizon. Sunlight has to travel through much more atmosphere to reach your eyes. Along the way, most of the blue light gets scattered away, leaving behind red, orange, and pink colors. That's why sunsets look so dramatic and fiery. So when the sun sets, it's not changing color, the sky is filtering the light. This same science explains why astronauts see a black sky in space. There is no atmosphere there, so no scattering happens. Without air molecules, light doesn't spread, and the sky remains dark. The blue sky is not paint. It is not magic. It is physics working silently every second. The sky teaches us something powerful: even the most ordinary things hide extraordinary science. What we see is not always what exists, it is how light, matter, and our eyes work together. So next time you look up at the blue sky, remember, you are not just seeing a color. You are witnessing sunlight dancing with Earth's atmosphere, a story written in light.